Um, well, welcome to Celestial Navigation. I'm glad y'all got on Zoom. We're going to start with some introductions and then get into some more details. So a lot of you have had classes with me at OCC, but my name's Bree, and I went to the Maritime Academy and have been sailing around the world for the last 10 years on commercial vessels. So I worked on container ships, oceanographic research vessels, oil rigs, training ships, and I think that was it. And I've worked my way up from the third mate or an unlicensed person to a third mate all the way to unlimited captain. So I have my unlimited captain ocean license, and unfortunately I can't go to sea anymore for some health problems, but I am really enjoying teaching navigation to you guys. But my caveat there is I am not a recreational boater, and I don't really have recreational boating experience. So some of the things that I talk about, I need to kind of transfer over to your guys' world. So please, if you're like, I have no idea what you're talking about, that doesn't happen on the boats that I on and experience, tell me and we can adjust. So I really want to make it valuable for you guys and the world that you are sailing in, even though I haven't been on recreational boats. So that's my caveat. If we can go around and introduce yourself and let us know what sailing or power boating experiences you've had and what celestial backgrounds you had. So I'll call on you guys and introduce yourselves. So let's start with James.
James Blake from Seal Beach, and lifelong sailor, and largely with smaller boats and getting into bigger boats now. And my experience with celestial navigation is bona fide rookie. So
Right,
I'm looking forward to the class.
Have you ever worked with a sextant at all?
Yes, but just in a, gee, what is this? How does it work sort of way. So, yeah.
Cool. And was that sailboats or power boats?
Sailboat.
Cool, cool, cool. All right, Robert.
Yeah, Robert Jones. I actually am a sailing instructor there at OCC, currently doing the basic cruising and cruising cert classes there. I took celestial navigation before with, I forgot who that was. But we didn't really do very well in the class. Our noon sighting was during June gloom, so we never actually got to do a noon sight. So I'm looking forward to getting more deeply involved in it during this class, not just the sights, but the how and why and all that into how it works.
Cool. All right, so you have taken class before, but no, you haven't done Celestial Underway or anything?
Correct,
Okay.
I have not.
All right, let's go with Ted.
So my sailing experience has been mostly on the West Coast, both Northern and Southern California. Actually, mostly Northern California in the Bay Area, with boats up to about 60 feet, both monohull and catamarans. I've crossed both oceans a couple times. In terms of celestial experience, it's basically all theoretical. I've gone through the U.S. Sailing CELNAV class, but that was years and years ago, and I'm quite rusty at this point. So this will be a kind of a review for me, and the U.S. Sailing class focuses on noon sights, and I'm hoping to get some star sights done as well.
Cool. Did you, when you're doing your ocean crossings, did you do any celestial or GPS?
It was all GPS. So yeah, like I said, my experience has been all theoretical at this point.
Cool. All right. Well, welcome. All right, let's go with Frank.
Hello, everybody. My name is Frank. I'm relatively new to sailing. My wife and I came back after a 5-year, I call it an exile in Texas. We came back to California. We were sitting over at 333 looking at all the boats. And we was like, wow, I want to do this. I want to learn. And we started at OCC, moved over to Windward Sailing Club with my buddy Tim there and Matt in the bottom. We met there. But I kind of went all in. I loved it from the beginning. And I've done navigation classes, bareboat classes. My wife and I did 12 days in the BVI. We did 5 days in San Juan up in Washington. I've done a couple of Bajas now. So I'm all in. I love it. Constantly trying to learn. I just bought a Beneteau 47, like right at the start of the pandemic. Like, who does that? That's just a bit of insanity. But it turned out to be a blessing because it's allowed me and my wife to just enjoy the boat and kind of not be quarantined. I don't feel quarantined. I have a boat I can really enjoy. And our dream is in a couple of years to just head out and sail around Mexico. And one sailor told me it's called keep the dirt on the left. You sail to Mexico, you go to Puerto Vallarta, do the whole Central America, go through the Panama Canal, and kind of just do that for a couple of years. So I thought it'd be smart to learn as much as I can about everything that I can in case my navigation blows up on me. So that's why I'm here, Bree.
All right, that sounds good. Well, welcome. All right, let's go, Tim.
Good evening, everybody. Frank and I are the sailing buddies from Windward. Been sailing from Windward for on my 7th year now. Still pretty much a novice at real sailing. Have done Catalina several times, and then just up and down the coast here. We moved out from Colorado 10 years ago, and I've always wanted to learn to sail. So took advantage of OCC just being down the road from me, and taking the navigation classes, taking the anchoring class, and have just really enjoyed being a part of OCC. If I'm not mistaken, I think Robert was in one of my navigation classes, and I think he's a trained pilot, if I'm memory serves me right.
I have flown, yes.
Yeah. In terms of celestial training, I haven't really done it with a sextant. I have a very strong background in land surveying, and to find out where the heck we were in the world, to locate points, did a lot of sun shots and used the thesaurus, and so did that kind of thing that I know is very similar to a lot of the celestial training that we'll get here.
Cool.
And so, so yeah, that's me.
All right, well, welcome. Quick question for you. Did you have any chart plotting? Did you take any of those classes at OCC?
Yeah, took Nav 1 and Nav 2, so did all the chart plotting.
Okay.
Yeah.
Gotcha. Tom is not here. No, Tom.
I am Tom. Yeah, I am here. Can you see me?
Oh, yes, you are here. Sorry.
Okay.
Gotcha.
All right. Well, I'm Tom Noto, and I am here. In terms of, I sailed quite a bit as a kid in Miami, which was quite a long time ago. And I think about 5 years ago, I decided, oh, what is this Windward Sailing Club? And so I'm also started back up at Windward, and then a year ago, took the plunge and bought a little 31-foot boat that I have up at Alamitos right now, and spend as much time on it as I can. Yeah, in terms of experience, I own a sextant because I agree with everyone. They're super cool. I bring it out, on the way to Catalina a lot, and every once in a while pull it out. Generally find that I'm somewhere in Arizona, but every once in a while I find myself in the Pacific.
That's good. That's good.
So, I know what they look like. I know what to twist and turn and whatnot, but have a long way to go and looking forward to it.
Would you do longhand
You know,
sextant calculator?
I use, there's that U.S. Power Squadron program where basically you just plug in, you know, the basically, you know, time. It's essentially time and the sextant reading, and from there on out, you know, maybe your elevation. It pretty much spits everything out. So.
Okay. Cool. Let's go with John.
Hey, good evening, everybody. John Tamoyan. I have been on boats on my life, probably 50% power, 50% sail. I taught sailing when I was in college, worked at a boatyard, worked at a marina, had my own yachting clients, did deliveries, kind of a little bit of everything. My longest passage, I did Transpac on Alaska Eagle in 07, which was super cool. And that was my only celestial experience where we did a few sun shots, just to sort of act really cool. And we sort of got it down on a pitching boat in the middle of the Pacific. But as far as the nuts and bolts and wheres and hows, that's, I'm an absolute rookie with that.
All right. Sounds good. Well, I'm excited. Let's go with Bill.
So I'm Bill Griffith, and I've been sailing pretty seriously for about like 4 or 5 years, mostly taking classes at OCC, like over and over again, because it was, you know, a cheap way to get out on a boat. And about a year ago, I joined the Oasis Sailing Club at Newport Beach. But it's mostly been all day sailing, and my biggest sailing adventure was I went to Italy with Mark, one of the other instructors at OCC. And we sailed around the Amalfi Coast for a week. So that was fun, but I'm just looking to get, you know, more information, and you know, maybe sometime I'd like to you know, charter a boat and do some exotic vacation kind of thing.
All right, and no celestial practice on those?
No.
Okay, cool. And Janice, go ahead and introduce yourself.
Hi, I'm Janice. Some of you know me because I sit behind the desk in the office. And I know I've talked to some of you in person when you've come in to enroll in the classes. Really glad to see you all here. I started sailing as a kid, and I've sailed pretty much lots of things up to about 100 feet. My family had a 56-foot motor sailor that we sailed to the Caribbean, and I spent a couple years there, sailed back. On that trip, we used Celestial. This was back in the day before GPS, and SatNav had just come out, but it was really, really expensive. So we decided to use Celestial Navigation. And so mostly did sun shots, moon shots. Stars were, sometimes we get a star, but we were often in kind of big seas, so it was kind of sometimes hard to get the stars. And but it was good. I'm gonna just kind of hang out in the class and get a refresher here. So,
all right.
And if Bree needs anything, I can help her out.
Thank you.
If you need something from the office, just let me know.
All right. Yeah, she's in the office. I don't even go down to Newport anymore. I'm up in Long Beach. All right, cool. Well, welcome everybody. So now I'm gonna have you guys pin my square so that you're mostly seeing me. You can see everyone else if you want to, but pin my square. So if you put your mouse on my face, you'll get 3 little dots, and then it'll say pin video. So go ahead and pin me, and then if you could mute yourself. So the mute is down in the lower left-hand side. And that's just so background noise is lower and all you're hearing is me. But if you guys have a question about anything at any time, feel free to unmute yourself and ask away. So just wanted to go with the Zoom, and obviously everybody has connected to Zoom. It'll be the same link for all of our meetings. The other pieces of information, I'm recording it so I can post it up for you guys to see on the YouTube channel if you wanted to go back to my explanations of things. So I'm going to start with a screen share. There we go. And we're going to go to Google Chrome. Okay, so can everyone see my my Gmail? Yep.
Yes.
Yes.
Great, great. So I am not going to email you every week like I've done in my past classes. I'm going to use the Google Classroom. So the Google Classroom here, let me go to just the beginning. Go to Google Classroom. You'll see the little plus sign in the corner to create or join a class. If you click on that and you want to join a class, the code I have on the on some of the emails, so it's just a strange code, but you just enter the code and push join. And so then you'll have access to everything in the Celestial Navigation course. So in here, I'll go to classwork. I have the Zoom link, and that's just a quick reference in case you didn't want to search your emails. Amazon links to pubs if you want to get a hard copy of the pubs, and I'll go over that momentarily. And then you have the course info and outline. I'll also be posting PDFs of our PowerPoints, so you can go back to those. I just have week 1 in there now. I do have all the assignments posted. Down here is your video tutorials. I think, yeah, I haven't posted the one for this week yet, but I will. So that'll be in there. And then answers to all the assignments are in here as well. And then for reference sheets, these are just kind of your cheat sheet reference forms. So you have a few of those. And then reference materials are PDFs of a lot of the materials and the pubs that we're going to use. So feel free to look around this Google Classroom, and hopefully most of the information that you need will be there, and I won't have to email you guys. With the video tutorials, I was going to show you here is my the YouTube channel. So I have a playlist for celestial navigation and coastal navigation. So my homework tutorials will be posted on the YouTube channel and on the Celestial Navigation playlist. And what else do I have up here? Oh, okay. So the other way I teach via Zoom is with the document camera. So I do a lot of whiteboard explanations as well as plotting on the chart. So when we get to chart plotting, you'll be seeing how I do it firsthand with the document camera. So you should be able to see me and the document camera at the same time, but this one in bigger form. So that is kind of how I'm going to be holding the class. Again, pop in with a question anytime. I like getting the feedback. It is going to be a ton of information coming at you real fast. When I took Celestial Navigation at the Academy, it was a semester-long course. When I taught it in Seattle, it was a 2-week course, 40 hours a week. So this is the most abbreviated course that I've taught Celestial. But I think it's going to be great. Just want to warn you, it's going to be a lot of information. So we have our course outline. Each week we have one homework assignment. So I've kind of just combined it into one assignment with a bunch of different topics. And then, so we'll do 6 weeks of instruction, intro to everything today. Next week we'll learn the Nautical Almanac. I highly suggest getting a copy of the Nautical Almanac because we are going to be flipping through pages a lot, and you can get it online. There's a PDF version on the Google Classroom, but there is just a lot of back and forth, and so I personally find it easier having a hard copy. Again, that's available on Amazon. And I think we have some in the bookstore. I'm not sure. But so our second week is learning the almanac. And then our third week, we're going to learn how to use the sextant. And then our fourth week, we do a full sight reduction. So we go from 0 to full sight reduction in 4 weeks. It's fast. Or 4 classes, sessions. And then week 5, we do kind of the easier or cheater ways, not cheater, just shorter, quicker ways to do lines. So we learn how to do the full line, and then we go back and learn how to do the quick and easy ones. So we'll do the quick and easy ones week 5, and then week 6, we'll learn how to prep and prepare for shooting our actual sites. And then on, so I see where it says Saturday labs. That's actually Sunday labs. We're going to do a noon site on the pier. So our noon site's going to be, we're going to have 3 sites, 1 before noon, 1 at noon, and then 1 after noon. And then for evening stars, we'll do all of our shooting at dusk or civil twilight.
Quick question?
Yes.
Will you be going over like a day in the life of a celestial navigator in terms of say you start with morning sites, then you do some noon sites, and then you do some evening sites? You know, kind of the not so much the sites themselves, but you know, how do you normally organize yourself while you're on a passage?
Yes, we can definitely go over that. It's mostly what you have time for, but I would say try to get an evening shot or a star fix, so either morning or evening stars, and then a sun fix. Easiest is to do it around noon, but we will go over how to do those fixes. So this is where I kind of want a little bit of feedback from you guys. I have on the schedule the Sunday for a noon site, I think, what is it, 11 to 2 or 11:30 to 2, and then Sunday 6:30 to 9:30. Now, when I had written that, I figured we would shoot our sites and then go to the classroom and work it out together. But we're not going to go to the classroom and work it out together because of social distancing. So we're going to kind of add in another Zoom meeting follow-up for those sites. So again, we don't have to answer now or anything, but maybe shoot me an email or something and we can do when the best time for the follow-up to that, or reducing the actual lab that we do. So yeah, just wanted to throw that out there. And some of you guys had some schedule conflicts. I'm more than happy to maybe do two days of sun fixes or 2 days of evening stars to accommodate, or you guys can do it on your own and ask me questions, whatever works. I'm open. Okay, let's go over the pubs. So Nautical Almanac, that is definitely needed, the 2020 version. And then we also need the 229s. Yeah, this is 229. So this is the site reduction table. Again, these are available online, but sometimes there's just a lot of flipping around, so I find it easier. So we will actually be needing 2 of them. If you just have one, that's fine. You can do the other one digitally. This is volume number 3, and that is 30 to 45 degrees latitude. But I do have some Hawaii examples. And this book got real beat up here. But it is the volume 2, 15 to 30. So for your Pub 229s, volume 2 and volume 3 to cover all of the problems that we have. Again, available on Amazon if you want the actual book. But they're also available digitally, so you could feel it out. And then my last one here is Pub 249. This is the selected stars. So this is going to help us on our last day, our last lab, of helping us find which stars we want to shoot. You could also use a star finder instead, or different, whatever one you want. So again, not 100% needed. You can get it online as well, or you can use a star finder. Again, not needed. You can do the digital version if you want. I just didn't want a ton of requirements for this class. But those are things that I will be using and showing you how to use if you're interested. This is another one we sell in the bookstore. The Quick Reference Celestial Guide. It's, plastic hard thing. So that's great to have on your boat. It has a site reduction form with examples and some explanations. So as you are learning with me, you can use this as well as a quick reference. So that way, when you're on board and you don't have your binder full of notes or anything, or my PowerPoints, you can look at this and be like, oh yeah, I remember what she was talking about. So I know we have this in the bookstore. I don't know how much it is. Maybe Janice does. And that is our materials. You'll also, oh, no, one more. Universal plotting sheets. Has anyone used universal plotting sheets before? No?
Yes.
No.
So with universal plotting sheets, we could kind of zoom in and focus on one area and have it simplified. A lot of times when we look at the small scale charts, if you're doing an ocean crossing or something, it is so hard to plot your lines of positions and assume positions in such a small area. So your universal plotting sheet, we can make it for any location, and we have and it's basic information. Obviously there's no land features. It's just for navigating, not collision avoidance or looking around you. It's just knowing where you are and to change course if you want. So you just create your own chart essentially. I know we sell these by the sheet in the bookstore. This is essentially what our celestial plot will look like. We have these in the bookstore. I'm pretty sure you could, or I get them on Amazon. So you can get them there too, you know, big pad. And you could erase and reuse them if you want as well. I think that is it so far. Does anybody have any questions?
Hi, it's Janice. I just wanted to let you know that we this year we don't have the 2020 Nautical Almanac at the store. We talked about it, but I think it's just probably easier for people to get it from Amazon. And we do have the Pard Plastic quick reference is approximately $10. Yeah. And we have lots of those. And we have universal plotting sheets. We sell them for 50 cents each, or you can get 3 for $1. They are printed on both the front and the back. So one piece of paper gives you 2 plotting sheets.
Yep.
Okay.
Cool. Thank you. All right. Any other questions? We're going to dive into the PowerPoint. All right. Let's do it. Sorry. Hold on. There it is. Okay, can everyone see my PowerPoint?
Yes.
Yes.
Okay.
Yes.
Great. I'm going to minimize that. All right, so we are diving into week 1. We're going to do our basic theory, different coordinate systems, and then we're ending with time. So let's get started. All right, so as a review in navigation, we have a couple different types of fixes. So we have that dead reckoning fix, and that is just a calculated position. We use 60 D Street, our course, our intended course, to just calculate that vector and create a position. So it has no other information besides what our estimated speed, estimated course is, and a last position. An estimated position has a little bit more information. It has either one LOP. Does anyone remember what LOP is?
Line of position.
Line of position, yes. So it either has one LOP or it has leeway, steering correction, current correction. It just gives you more information than just one dead reckoning fix. The running fix is 2 LOPs, but at different times, 2 or more LOPs, but not at the exact same time, where our fix is LOPs that we get right at the same time. So we're saying that all of these things are happening at the same time, and we can get our LOPs that way. So we are going to be working on mostly in the running fix category for our celestial. The running fix category, why we do it is because for our sun lines, we have, they happen at different times. So we have to adjust or advance or retard them to a single time to get a position. With the evening stars or morning stars, you're not exactly getting them at the exact same time. So if you're hove to and getting them, or if you're underway, you're usually getting them within, 2, 3, 5 minutes of each other, and advancing or retarding those lines has very minimal change on your line. Of course, you can, and sometimes I do, if I want it to get a real pinwheel. Pinwheel is the one where your lines, your 3 lines cross, exactly the same point. Cocked hat is where they form a triangle and you have to guess where you are in between. Moving on, our lines of position. So from these types of fixes here, we're all using lines of position. With our lines of position, we can use different things. Our most common for our coastal navigation courses were visual bearings or radar range for a distance. So you have your visual or radar bearings, your distances you can use. You have the fathometer, you can use what's underneath you. Then you have the old Lorentz, Deca, hyperbolic. But the one we are going to focus on this class is a celestial. So all the work that we're doing to measure, we are just getting one line of position. And then we have to apply all of the knowledge that we got from other courses to actually get that fixed too. So we are getting a line of position, and then we have to use all this other information to actually get a fix and go into the navigation realm of it. The other aspect of celestial is compass error. We're not going to go into that in this class specifically, but that is another huge part, and I would say in the commercial world, more used than actual line of position. In the commercial world, we use celestial mostly for compass error, and we do our regular fixes mostly by GPS. But compass error, just like if we were getting a bearing of a true object or a range of a true object on a chart, if you were near it, you're just going to use a star or the sun or a planet or a moon as that aid to navigation. So that really brings us to our next slide. Again, with regular coastal navigation, you are getting bearings off of aids to navigation or points of land or things that are plotted on the chart. Remember that the criteria is it has to be plotted on the chart for you to use it as a aid to navigation. In celestial, we are going to use the stars, and there are 57 navigational stars, and then there's an additional 172 suitable stars. So the list of all those stars are in the almanac. If you just go to the middle of the page, the navigation stars are listed here, and then your suitable stars are in the back. We also have navigational planets, which we have Venus, Mars, Jupiter, and Saturn. We have the sun, we have the moon, and then we have the North Star, which is Polaris. So those are our aids to navigation, or those are our things that we are going to be getting bearings and measuring from so we can get more information. So instead of using buoys and lighthouses and points of lands, we're going to be using these stars and planets. So again, you can, but using the almanac, they have 57 navigational stars and then 173 suitable stars. So you'll want to shoot one of those 57 stars, and we will go into that. But that is why I want to say on that. Any questions so far? All right. So we're going to dive into that star or the moon or the planet. I'm going to say star pretty much from here on out for our lecture today. But when I say star, it's really the sun, the planet, the moon, whatever celestial body that you're observing. So if I really wanted to get a laser pointer for this, but I didn't. But I do have a celestial globe. So on your celestial globe, the geographic position of the star is obviously in the celestial sphere of things. And if you had a laser pointer and pointed right on through the star to the Earth's surface, to the center of the Earth, that would be that geographic position of your star. So we'll have a position of the star, wherever it is, a geographic position of the star. But we're going to use different terminology, not Latin long. We're going to use declination and GHA, which I will go into. But the geographic position of the star is just where the star is directly below it. So directly below the star is the geographic, or the GP, of the star. Other points of interest here are, or vocab, I guess this is what we're going through, is the first point of Aries, or point of Aries, whatever it is. Which for this class, we're going to think of it as kind of like a reference point or a datum. It's a point which we take all of our astronomical measurements from, specifically stars. So what this is when the Earth, or in this picture here, you see the equator is here, and then this circle here is the ecliptic of where the Earth rotates, or the sun rotates around the Earth. So if you guys have noticed, you have the, where is it? Tropic of Cancer, the northern hemisphere, and the Tropic of Capricorn in the southern hemisphere. And in between those two are the tropics. Why they are the tropics is because the sun is directly above them. The sun never passes above that 23.5 degrees, which is the Tropic of Cancer, or the 25.3 degrees south, which is the Tropic of Capricorn. So if the sun is up here, it's summertime. If the sun is down here, it's winter. So when it's directly over the equator, that is what they call the first point of Aries. And that is that reference point that we use. We're not actually, measuring the first point of Aries. You're not going to see it as a constellation. You're not actually doing anything to it. It's just a reference point. Does that make sense, though?
Bree, just a question. My recollection was the first point of Aries is actually the location in the Aries constellation.
That is not.
That is not correct?
That's not correct.
Okay.
It is not in the constellation. It is when the sun passes the equator. So it's when day and night are exactly the same when it passes the equator, kind of in that transition from summer to what is it? It's a vernal equinox, I want to say. Is that what it? Did I put it on my notes?
Yes, that's correct.
Vernal equinox. Yeah. So it is not a constellation, not a point in the sky. Okay. Our coordinate systems. So for terrestrial navigation or coastal navigation, what we've been learning up to this point, we use latitude and longitude to figure out or to say where we are. Again, our latitude are parallels, and you have 0 to 90 north, 0 to 90 south. And our longitude is from Greenwich, which is going through Europe there, and then 180 west and 180 east. So we have our longitude and our latitude, and that's what we use for terrestrial navigation system. So hopefully we're all comfortable with that, because now we're going to introduce 2 more systems into our vocabulary and our brain. We have the celestial equator system, and then we have the celestial horizon system. So first we're going to go into the equator system, which is going to be very similar, or not very similar, but easier to visualize or comprehend, I guess. It's similar to our basic terrestrial system. So on our equator system, the celestial sphere is the celestial sphere around the Earth. So the Earth's equator projected out onto the celestial sphere is the celestial equator. So it is just like the Earth's equator, kind of that reference point. Then you have the celestial poles, the North Pole and the South Pole, same as the North Pole and South Pole of terrestrial. Then you have the meridians. Meridian is another word for longitude. So that meridian is a great circle. So great circle is a point where it passes through the entire globe. So I really wish I had laser or something. Like the equator is a great circle, and all of your longitudes are great circles because it literally cuts the sphere in half. And all of your meridians pass through both the North Pole and the South Pole. So our celestial meridians are doing the same thing. They're going through the North Pole and the South Pole, or the celestial pole. Your hour circle is a great circle that passes through the poles. So that's just like a meridian is an hour circle. It's equivalent to longitude. Your declination is going to be that angular distance from the celestial equator to the body itself. So that's going from the equator to the body, just like latitude starts at the equator and then goes up to the position of where you are. It's going up to that geographic position of the star. Your hour angle, so again, there's our circle, is that point of longitude. Your hour angle is how we are going to measure that. So just like in longitude, we start at Greenwich. Just like in there's Greenwich. You start in Greenwich and go west or east. With our hour angle, we can start at Greenwich and go west, and that's called a GHA. So it's our Greenwich hour angle, starting from Greenwich, which goes 0 to 360. So it doesn't have that east or west like longitude does. And then you have your local hour angle, which goes from you, wherever you are, maybe we're over here in California, to wherever that body is. Maybe the body is over here. So it's that angular distance instead of starting at Greenwich. So even if you're down here and the star is up here, it's just that difference in longitude, DLO. It's not longitude, it's going to be hour angle, but that might help you conceptualize. It's the difference in meridians or the hour angles between those two. So it doesn't matter which northern southern hemisphere you're in. It's just the hour angle, the difference in the meridians or the hour angles. Meridian angle, or little t, I feel like I always call it little t, but it's meridian angle, is just like LHA. It's from you, wherever you are, to the sun or the moon or the planet, wherever it is, geographic position. And it's the shortest distance. So it can either be measured east or west, but it's always from you to the star in the shortest possible distance. And so you have an east or a west measurement. But I try not to get that confused with, hey, I'm in the Eastern Hemisphere, but that star is west of me. So your little t would be west, even if you're in the Eastern Hemisphere. So it doesn't go with, the longitude. It goes with where it is from you to the star is your meridian angle. And then our last one is SHA, which is the sidereal hour angle. And that goes from Aries to the star. So our point of Aries is always moving just like the sun does. Again, it's not a thing, it's just the reference point. So we are going to reference where that hour angle of Aries is to the star. And that's always measured west. So I'm going to show a bigger picture of this and kind of talk through it again. So again, we are starting with the equator system. So we have our celestial equator here, and then we have our Greenwich, our meridian of Greenwich. So in longitude, that would be 0 longitude. In the celestial equator system, that's just 0 for Greenwich. If we measure west, we're saying our observer is right here. That would be called our longitude. So we're comfortable with that one. If we measure from Greenwich all the way to where the star is, that would be called the GHA of the star. So that's the Greenwich hour angle of the star. This is the hour circle of Aries. So this would be called the GHA, or the Greenwich hour circle of Aries. That little symbol there is the symbol for Aries. So you'll see that a lot. And then we have the local hour angle. So that's from the meridian to the hour circle of the body. So not from Greenwich. So it's from the local meridian to the hour angle. And again, in this photo, the star and the observer are in line, or declination or latitude wise, they're in line, but it does not have to be that way. Your star can be up here and you could be down in the southern hemisphere, or either way. It's not, you're not going to see it if you're in the southern hemisphere, but my point is that declination doesn't have to do with your GHA or LHA or your latitude. This is another image of it, I guess. I like my images. You don't have to see me drawing it on the board anymore. So wherever the star is your geographic position of the star. To get that position, you use your hour angle and your declination. So your declination starts at the equator and goes up maximum 90. So that's just like latitude. And then you have that parallel of declination, just like latitude. You have your parallel of your latitude. Same explanation here, it's just a different picture. You have your parallel of declination. From the pole to the star is called polar distance or co-declination. And we're going to go into that when we do our navigational triangle. So from the equator to the pole is 90 degrees. We can get from an almanac the declination. So that's from the equator to the star. So 90 minus declination would give us our polar distance. So that's a new vocab word to throw at you. Okay. Any questions so far on those vocab terms? Okay, we're gonna.
One question, Bree.
Yes.
You say polar distance. Is that the same as zenith distance?
No, that is not. We will go into what zenith distance is on the horizon system.
Got it. Okay.
Polar distance is on your equator system.
And a question on LHA, that is always to the west?
Correct. Always measured to the west.
Okay.
So you don't have to have a sign on it, and it can be 0 to 360.
Okay.
Always measured westward. Your little t or meridian angle is the exact same definition as LHA, but that one's measured east or west. So it can be either 0 to 180.
Okay.
Hey, Bree, one more. And on that left-hand diagram, the hour angle, I'm assuming that's the SHA, right? Because
so this one is, they just said celestial meridian here. They didn't
I'm assuming
say
that's Aries, right?
the Greenwich or the local.
Okay.
So, so if this was Greenwich, it would be Greenwich hour angle, or if this was the local or your longitude, it would be local hour angle.
Okay.
Or
and if it was Aries, it would be SHA, right?
Yeah, if this meridian was the central meridian for Aries, it would be SHA.
Got it. Okay.
So it just didn't put that specifier.
So it depends.
Yeah, it depends.
Okay. Got it. Thank you.
Okay. Okay, so now we're going to dive into what we call time diagrams. Our time diagram is a quick and easy way to, okay, I'm not going to say easy. It's a quick way to understand where the celestial body is in reference to you. So to me, it's a great way to conceptualize things, but in practicality, it's not something you're really going to draw out on board. If you get some like crazy numbers or you end up in Arizona or something, then maybe you can draw out your time diagram and, oh, it should have been 180 minus that, or 360 plus that, or, I added when I should have subtracted. It's just an easier way to visualize to make sure our numbers make sense and can do that mental check of like, oh yeah, that seems right. So that's why I like to do time diagrams, because it's easier to do that mental check. Otherwise, you're just looking at all these numbers, no idea what they mean or if they're right or not. So, so we'll do a little introduction to time diagrams. The time diagrams are always viewed from the South Pole. I don't know why this is like that, but all of the textbooks, Bowditch, Chapman's, Dutton's, all have your time diagrams from the South Pole. So that's where we're going. So if we can imagine, the center of our circle is going to be the South Pole. So if we have Greenwich, that's going through Europe and Africa, right? And then if we're going west, we have South America and North America. We have the prime meridian, which is opposite of Greenwich. And then you have Australia and Asia. So from Greenwich, you can either go west or east. That's why we have our west or east thing. Our rules we're gonna look at is our GHA is measured from Greenwich to the star, measured westward. Our LHA is measured from me to the star, SHA from Aries to the star, and then our meridian angle, or little t, is east or west, whatever one is smaller. Oops, and that means nothing, that That was a mistake there. But with your little t, you must have a sign. It must be east or west. So let's look at an example. So this is an example from, probably from Bowditch. So you have Greenwich, which is, you know, your Greenwich line. And then, so this is that international date line, your prime meridian. So your longitude, that's a little symbol for longitude, is to wherever you are. Again, this whole thing has nothing to do with latitude. So it's all in reference to longitude or your hour angles. So from Greenwich, you are in the west. So whatever your longitude is, according to this, I would say 045 degrees west is your longitude. And then we have the moon. So your GHA of the moon, that is going to be here, goes from Greenwich, GHA, to the moon, measured westward. If you want to look at LHA, that's the local hour angle. So that's from me, M, to the body itself. So that number is going to be smaller than our GHA. Then we have Aries. So your LHA of Aries is from me, or your GHA of Aries is from Greenwich. SHA of the moon would be from Aries to the moon. And then we have it, this is the symbol over here for the sun. So we have GHA of the sun goes all the way from Greenwich all the way over to where the sun is. And then if you have local hour angle, goes from you all the way over to where the sun is. So the smaller from you to the sun would be measured east, and that's where we have a little t. We have an LHA and a little t. So on here, any guesses? Is it AM or PM? All right, who votes if it's AM?
AM.
All right, who votes if it's PM?
PM, I do.
PM. Okay.
PM.
PM.
Okay. If the sun, so the sun rises in the east, sets in the west. If you look at your almanac, you can see that your GHA is increasing. Your GHA is always getting bigger and bigger, and then it gets to 0, and then it goes bigger and bigger. So your sun is rotating around the Earth. I mean, yes, we're rotating around the sun, but in time diagram things, the sun is rotating around here in the counterclockwise motion. So if the sun is right in line with us, that would be noon. If the sun is right in line with opposite of us, this little m, that would be midnight. So the sun is somewhere between midnight and noon, so it would be AM. If the sun was came past noon, this area would be PM. Does that make sense?
No, it was a lucky guess. I said AM. I was a guess.
Good guess. Good guess. All right. So this can also tell us, like, hey, if I shot that and it was in the afternoon, it was a setting sun, the sun shouldn't be over there or shouldn't be on that side. Maybe my numbers are wacky, or I need to readjust something. I was looking at the wrong page or the wrong year or something. So it's just a good way to visualize. Again, you're probably not going to use it practically, but I like to do it just to do that double check thing. This was another picture of it I found, same type of thing. Okay. That is the celestial equator system. Any big questions on that so far?
Nope, but I think someone needs to mute their line there. I'm hearing a lot of heavy breathing.
I don't know who's on there. Okay. So now we're going to go to the celestial horizon system. So we're going to kind of switch our gears and think about things in a different way. So the celestial horizon system is all referenced from where you are. So your boat, wherever you are, is kind of the center of the celestial horizon system. And if you have a plane that goes directly out from where you are, that is the celestial horizon. So directly out from where you are is your celestial horizon. Directly above your head, so if it's a point from the celestial sphere through you, through the center of the earth, and out to the other side, that is called your zenith. So we're not talking about the North Pole anymore. We're not accessing things around the North and South Poles. This system, we're accessing around zenith. And then down opposite of zenith, below you, is called nadir. So you have your zenith and your nadir line, and that is just a reference point from where you are. And then you have this celestial horizon plane around you. And somewhere on that celestial horizon plane, you have all of the stars and the planets above you, right? All your stars and planets are somewhere where you saw them because they're above the celestial horizon. So from that point, we are going to see what the angle of the star or the sun or planet, whatever it is, the altitude of what it is from your celestial horizon to a star or whatever. And then you also want to know what its bearing is. So where is it? Is it to the east, to the west, to the south? Where is it on the celestial horizon? So let's dive into the actual definitions here. That was just my quick explanation. Celestial horizon system, based on the observer. So you are the center of the celestial horizon world. So you have a plane that is perpendicular to your zenith nadir line. So that zenith nadir line is going through you, and a perpendicular line to that is the celestial horizon. So they specify celestial horizon because it will be different than the visual horizon, or different than the Earth's horizon, different from, there's a few different types of horizons there, but the celestial is perpendicular to the zenith nadir line because of, oh, I have it here, because of refraction and height of eye, that you might be able to see past the celestial horizon, or you can't see the celestial horizon, depending on different things. So zenith is directly overhead. Nadir is completely opposite, goes below you. So in our equator system, we had what we called hour circles. In this horizon system, we call them vertical circles. So these vertical circles are going to pass through the entirety of our celestial sphere, our globe here. So your principal vertical circle passes through the North Pole and the South Pole, and your zenith and your nadir. So, so it's passing directly through you. It's, you know, perpendicular to your horizon, and then it's also passing through the north and the south. And then your prime vertical circle passes through the east and the west. So let me click through here. I felt like adding a little circle here. So it kind of becomes this plane system, if you will. This is where I wish I had a laser pointer or something. A 4-plane system passing from the north and the south, the east and the west, and they're all passing through the zenith and the nadir. So we're kind of got this quadrant thing going. Let me go back to this one. So, here's the image. So it's a line for your prime vertical circle. It's passing, wait, did I get that right? No. Principal vertical circle is the plane that's passing through your north and south in your zenith, where your prime vertical circle is passing through east and west and your zenith. So it's passing that way. So you kind of have this quadrant on your horizon. Okay. Click past that. Again, these are some more pictures. Some people visualize different things, so I put a lot of pictures on here. Passing through your zenith and your nadir, and it's passing through the celestial poles. It's your principal. If it's passing through the east and west, it's the prime. So this is where we get real crazy with our little diagrams here. So this light blue is our celestial horizon. And then right above us is the Z, or the zenith. And the N is your nadir. So all of our vertical circles are going to pass through both of those. So we have the elliptical of the star, and then our prime goes through the North Pole and the South Pole, and I keep getting that. Our principal goes through the North Pole and South Pole. Our prime goes through the east and the west. Hopefully that makes sense. The other thing that we talk about, besides from those circles and referencing those, is the main thing is our altitude and our azimuth. So from us, here's us, whatever the height from the celestial horizon to the body in question is the altitude. So if we measure from zenith, if zenith was directly above us to the star, that would be your co-altitude, or the zenith distance. Remember I said polar distance was the opposite of like latitude or declination? Zenith distance is the opposite of your latitude. It goes from zenith, which is right above you, to the star. So that's what our zenith distance is. And then our azimuth is the bearing, and our bearing is going to be from north, or that principal vertical circle. So our, just like a bearing that we were to get, you know, of a lighthouse or something, it's from, we measure it from north. Unless you're doing a relative bearing, then it's measured from your heading. But in this case, for azimuth is going to be from north, and it's going to be where it is on that celestial horizon in the angular direction.
And this appears to go east.
What was that, Robert?
This appears to go east.
Correct. So it's just, it gives you a, just like north, if something was bearing 090, it's to the east. It's the same bearings as you have on a compass.
Oh, okay.
So visualize the compass on this one, just like you're taking a bearing of something.
Okay, I got it.
Okay. A bigger picture of it. So yeah, just like if it was bearing, you know, over here, it would be south. If it's bearing over here, it would be east, whatever the bearing of it is according to the compass. Same picture that I was looking at earlier. Okay, any big questions on the celestial horizon system?
Yeah, you had said that it's, or it looks like the azimuth is always east, but there's something about it's only 0 to 180 on the PowerPoint that you just had earlier.
Yes. So your celestial equator system. Let me get through here.
No, it was way after where you are right now. It was a one slide back from where you started there.
This one? Oh.
No, yeah, keep going forward. Keep going forward. Right there. Whoop. Back up one. Right there. It says the Z is the smaller angle of 0 to 180.
Okay, yes. So Z, so we have Z and Zn. Now, your Zn is going to be the azimuth from north. But when we get to our navigational triangle, we sometimes using the opposite of north because our angle of it would be outside of the triangle. So if it's smaller than 180, meaning it has to be inside of a triangle, it will just be labeled as Z. And that will make more sense when I get to the navigational triangle slide.
Okay. I was confusing Z and Zn there.
Yes. So Z and Zn are both considered azimuths. So they're basically referencing the same thing, but one is outside of the navigational triangle, and we have to put it back inside and then be able to reference it on a chart. So that's why you have Z and Zn.
Right.
Let me get to the navigational triangle and make more sense. Okay. Okay, so the navigational triangle is combining both of these systems into a triangle, and the basic trig of trigonometry of this is if we know parts of the triangle, then we can calculate the missing pieces. So we're going back to our basic trig geometry lessons of a triangle. So we have, we start with 3 points. We start with zenith, which is you, right? We start with wherever you are. Then we have the geographic position of the star, wherever that star is. And then we have the elevated pole. So that could either be the North Pole or the South Pole. If you're in the Southern Hemisphere, the elevated pole would be the South Pole. Northern Hemisphere, North Pole. So our 3 points are our me, the star, and the pole.
When you say elevated pole, you're talking about the celestial North and South Pole?
Correct.
Okay.
Then we have 3 sides to the triangle. I wish I had this on the board too. I can do a little whiteboard thing, but I can't do PowerPoint and whiteboard. So then on our 3 sides of the triangle, we have going from the star to, I wonder if I could do it like this. Would you guys see this if I could draw it? I'm gonna draw it.
Go ahead and draw it. I'll let you know.
Okay. Okay. We have the North Pole, the star, and me. So those are our 3 points of the triangle. I wonder, our triangle is spherical trig, so it technically is connected with these, instead of straight lines, we have spherical lines. Again, I'm not an artist. here's our point, here's our point, here's our point. So on the Earth, if we are measuring altitude, I'm not going to start with altitude. I'm starting with declination and latitude. If let's start with latitude. If this is the equator, our latitude would be from me, or from the equator to wherever I am. So our co-latitude is from the pole to wherever I am. So this side would be co-lat. And with polar distance, our declination is from our celestial equator to the star. That's what declination is. So our co-declination, or polar distance, is that distance from the elevated pole to the star. So declination is from the equator to the star. So far, this is the equator system, right? Now we're going to throw in the horizon system. So I'll draw a little picture down here. Here's me. Here's the star. And this is zenith. So if I have zenith is right above me, and this is my horizon, the angular distance from the horizon to the star would be your altitude. The zenith distance is from zenith to the star. So that would be co-altitude or zenith distance. And that's what the third line of the triangle is. So our third line of the triangle is our zenith distance. And I probably have a pretty picture of it somewhere, but this is my basic drawing of the picture. Wait, then we're going to go into angles. So far that's sides, so our points and our sides. Then we have angles. So let's talk our two basic angles that we're going to look at. We're not really going to look at our third. But if we go back to looking like GHA or LHA from me, so my hour angle is this co-latitude angle. Measured westward would be our LHA, but I need it to be inside the triangle. So this would be my T measured east, my little meridian angle. And then my azimuth angle, just like if we were looking at a compass, you know, on a chart or something, is always measured from north. And north is going directly through you, headed north. So that would be from you, or from you, north line, to whatever object you are looking at in question. So that would be our Z or ZN. And then the parallactic angle is from between the star going to you and the North Pole. But we have no way to measure that because we're not at the geographic position of the star or anything. So we're going to forget about that point. But just in case you want to know, if you're in trivia night or something, parallactic angle. Okay, let's see if I have some better graphics of this. That's already better. Okay, so geographic position of the star position of me. Your co-latitude is opposite of your latitude, or 90 minus. I think that's called complementary or supplementary in geometry. Forget which one of those I am. But your polar distance is from opposite of declination. So declination is how far the star is above the equator. Polar distance is how far it is away from the pole. Your co-latitude, co-altitude is also known as zenith distance. And that is 90 minus your altitude. So that's where the celestial equator system comes into play. Okay, this is where we have a better example of our Z versus ZN, and if they're outside of the triangle or inside the triangle. So here we have the North Pole, which is pretty much the one I drew, I think. We have the North Pole with the observer and the star. So the star is to the east of us. So our LHA is really big, and our meridian angle is really small. Over on this side, we have the star to the west of us. So our LHA is less than 180. And that means from north, because our zeniths are always measured clockwise like a compass, what we would calculate is our Z. And in order to plot it, we'd have to go convert it to ZN. So from north, measured this way, would give us ZN. If we're in the southern hemisphere and the star is to the east of us, we have a large LHA. And then our Z and ZN are going to equal 180. So because it's measured from north, our ZN is what we use to plot, but inside our triangle, we would only have Z. If the star, if we're in southern hemisphere and the star is to the west of us, our LHA and meridian angle would be the same. And in this case, our it would be 180 plus Z would give us ZN, because that zenith, that line of going north to south, Z, we'd have to add 180 to it to get what our actual bearing of it was to plot. Does that make more sense, Ted?
Not yet, but my my recollection is to do the celestial navigation, you really don't need to understand this. I mean, it's a great explanation, but my recollection is this is not really needed to do the sites, correct?
Correct. The thing for the explanations here. Sorry. Stop it.
I guess your dog agrees.
Yeah. Is if your numbers come out crazy, if you have a general grasp of what your numbers mean and what they should be, then it's easier to catch that mistake. It's easier to do that mental check of my number should be somewhere, 270 to 360. I should be getting something in that range. So yes, we will get to, the site reduction form where all you have to do is plug in the numbers. But yeah, this is the explanation of what all those numbers mean.
Understood.
Okay. Okay, this was the picture on your reference sheet. So you have the geographic position of the star, the position where you are, and I feel like it's the same that we've been going over. Let's look at another one. Okay. Okay, one more crazy thing, and this is where we we actually plot a line of position. So we gathered up all of this information and we go into our Pub 229 and we calculate an assumed position. And that assumed position is supposed to is not where we are, even though assumed position is like, this is where I think I am. It's not a DR position. It's an assumed position that we use to calculate something. And then we plot our intercept and we get our line of position. So if we change this back into what do I want to say? Terrestrial navigation, and we have the star or the lighthouse or buoy. We always have a bearing line to it. And this is a range line. So when we're measuring the height of the star, we're basically kind of getting a range line, if you will. And so it's essentially a circle. But this circle is going to be an hour circle. So it goes over the entire world. So we plot it as a straight line. So the line that you are getting is like a range from a star or from a point of position, from a buoy or a lighthouse or something. You're getting this range from it. And that's what we're measuring when we measure our angle of the celestial body. So technically the line of position is an arc, but because it goes over the entire globe like the equator, we draw it as a line. Then I'm going to throw in an exception, and it's called high altitude sites. So if you are, and I know it's in the almanac, I think it's 10 degrees. So if your altitude is between 90 and 80, that's a high altitude site. And you would plot it as a circle, not a line. And that's equal lines of, I don't know, high altitude sites are plotted as circles. But in this case, we are not going to be doing high altitude sites. But if you are, anyways. Okay. Any questions? We take a breather? All right, let's take a little breather. It is 8:06. Let's come back at 8:20. So grab whatever you need to grab and come back at 8:20. Or come up with some more questions. All right. I will. Any burning questions out there? How you guys feeling about things?
So, Bree, one of the things I always found confusing was when everybody talks about the distance. Everybody, you say that I forgot all the terms now, but they'll say like zenith distance or something, and they're really talking about an angle. Correct. And when I hear distance, I mean 6 feet or something like that, not 37 degrees.
So everything here is measured in degrees, and they're differentiating the angle as in the inside of the triangle to the distance as in the legs of the triangle.
Right, right, okay.
But all of them are all measured in degrees.
Okay, right, okay.
So even even a leg of a triangle isn't measured in nautical miles. It's measured in degrees.
In degrees, okay. And
Yes.
because that's the degrees of latitude or longitude, or?
Yes, kind of like difference of yellow, or yeah, it's the degrees on the celestial sphere.
Gotcha.
Because it's that globe, that celestial triangle, that spherical triangle that
Right.
we are measuring.
Right.
So we measure it in degrees, but it's a leg of a triangle, not an actual angle of the triangle.
Right. Yeah. I
So-
kind of get it, but it's counterintuitive.
Yes, it is counterintuitive.
Yeah. Okay.
Yes. All right, any other burning questions so far? Are we just mind blown over this stuff?
Yeah.
A lot of information to get in one night.
Too many coordinate systems.
Too many coordinate systems. It's a lot to get. There's probably some great YouTube videos out there. I should look at some and send you guys some links to some more. But I'm gonna put this on YouTube, my little lecture here. So so you can go back and reference it, or go back to the PowerPoints and reference it. I haven't read Celestial in a Nutshell, but I think that's a good reference to use. I use Bowditch, Dutton's, and Chapman's, which are very wordy, intimidating textbooks, but it all has the same information.
So, Bree, I was encouraged by one of my colleagues who said, so this is a lot, but it's not as necessary for the actual measurements. I took a deep breath of thank you when I heard that.
Yes. For actually measuring, you'll get this kind of long, it's called a site reduction form, or kind of like an equation of where to add and subtract. And all you're doing is plugging and chugging those numbers, and then you can get it. So all of this theory or intro, day one, is grasping what all those little numbers mean. GHA, LHA, you know, all these little
Makes sense.
little numbers mean. But again, you don't really have to, like, even when I took the class and then we navigated celestially from San Francisco to Tahiti, I didn't really grasp what it was. Excuse me. It really wasn't until I started teaching it that I was like grasping the theories behind it. So yes, you don't really need to know it all, but I don't know. I'm telling it to you anyway.
I just wanted to throw this out there. When I was reducing celestial sites, one of the things I always did was make a little sketch that showed me in relation to where the star was, and so that, because there were times when you have to correct and apply different factors. If you don't apply the right one time I reduced the site and it said we were in the mountains of Costa Rica. So it makes it easier to figure out what you did wrong if you have a sketch sometimes that looks like those navigation triangles, because you can kind of visualize in your head what's going on, and sometimes you can get to your error more quickly. So
yeah, but again, you don't really need to know it all.
And the sketches I made were very simple.
Yes, yes.
But just, you know, where is that star in relation to where I'm sitting right now?
Yeah. Yeah.
Hey, Bree, you mentioned a book. I want to make sure I wrote it down. It's called Celestial in a Nutshell.
Yes. Is that correct, Janice?
Yes. And
is that like a Celestial for Dummies kind of book? Simplifies everything?
I haven't really looked
Robert's
at
trying
it, but
to show it to us, but it's in a
It's fading in and out.
Oh, there it is. There it is. Yeah, it's soft cover. It's not very thick. So they had to simplify it a lot, I think.
Yeah, it is actually a much more approachable treatise that doesn't use a lot of celestial triangles, but it does show you what you need to do from a day-to-day standpoint.
Thank you, Robert. Tell me again what that form, that plaque you had that you said we can get at OCC. What is that called?
Oh,
quick reference guide. Thank you.
yes.
David.
And we have those in the bookstore or at the office. I was just going to say, if there's anything that you need to purchase from the store, if you give us a call ahead of time or send us an email, we can put the order together, and all you have to do is come in and pick it up, or we can also ship it to you if you don't mind paying the shipping.
And I've created site reduction forms for different sites for moons, stars, planets, etc. And they're in the reference sheets on the Google Classroom. So you could just print those out if you want to use those. So let's get more into a practical thing, less theory, right? We're going to dive into time. So let's get my PowerPoint back. Okay, so we are back in time. So time is a huge part of celestial. Literally every celestial observation you get has to be accompanied with a time. And time is different, and we all want to know which time we're referencing. There's different time zones, there's different watches, there's your stopwatch, there's your GPS time, there's your chronometer time, there's all these different ways of measuring time. So in general, the basic concept of zone descriptions is you have your prime meridian, which is your zone description of 0. So your prime meridian or zone description of 0 can be lots of different things. It could be Zulu time, it could be GMT, it could be, which is Greenwich Mean Time, it could be UTC, Universal Time Clock, Zulu. Those are the basic ones that you'd see it referenced. But if the sun is right on top of Zulu, the sun, rises in the east and sets in the west. So if you're anywhere to the west, it's still AM, or the sun hasn't gotten there yet. So you'd have a zone description of west, and all of these zone descriptions are pluses. Zone description east is the sun has already passed you. So it's 1 p.m. over here if the sun is on this side. On your zone description, they change at 15 degrees. So 15, 30, 45, 60, 75, et cetera, all the way to 180 is the central meridian for that zone description. So for zone description 3, the central meridian is 45. So if you are anywhere from 7.5 degrees, so that's 30 to 37.5 degrees west to 55.5 degrees west, if you're anywhere in between those two longitudes, your zone description is +3. Now, in the United States, we have, jagged our lines through states. So our zone description isn't exactly changes at the mark. It changes with state. But in the ocean, that's how we would calculate it, dependent on our longitude. And we use, I think I'll go into it. So let me get to the next slide. Let's see. Let's dive into it. Okay, so time. We have a couple different types of time. We have solar time, lunar time, and sidereal time. Solar time is exactly 24 hours, so that's what we will always use. But that's the interval between when the sun crosses the same meridian. So from noon to noon, that sun crosses the same meridian would be 24 hours. Sidereal rotation of the Earth is 23 hours and 56 minutes. So those stars, like if Polaris were to pass you, or Polaris isn't going to pass you, it's always pointing north. Whatever constellation is to pass you, that takes, that moves faster. And lunar time depends on the moon, which I'm pretty sure is slower, but I'm not exactly sure on that one. For some reason, I didn't write it in. Okay, then we have our apparent time, mean time, and zone time. So apparent time is based on your personal meridian of where you are. So if you are to the very, very, very east of in that zone description, okay, I'm writing our zone description. What are we at right now? We're at 8, 7. I'm saying 8. Let me write this out real quick. 8 times 15. Oh. 20 degrees west, and this is plus 8. Okay, so here is our stretched out zone description with longitude. So if we are in +8, our central time, central meridian would be 120 degrees west. If we are anywhere from, what is it? What did I say? 112.30 to 127, we are still going to be in that same zone time. So that's what zone time is. Everywhere in this whole zone is zone time. But if we are over here, the sun is going to pass us on our noon position before it gets to the noon, the technical zone time noon at that central meridian. Or if I'm over here, my apparent time would be later than my zone time. So apparent time is based on your personal meridian of where you are. So it's when the sun is at the highest point in the sky. So the sun rises, 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 and then it sets, sets, sets. So at that highest point is noon. So your local apparent noon is noon at your meridian, not at the zone time, at your personal meridian. Mean time is exactly 24 hours, saying that the sun travels at exactly 15 degrees per hour. Your zone time is everything within your zone description. LMT is local mean time. which is pretty much local mean time and zone time are the same. Then we also have daylight savings time when we're holding a different zone description than what we should. And then we have our GMT, Zulu, UTC, UT, universal time is UT, universal time clock. It's not working. Okay. So I guess the big thing I want to say is you have your apparent time and then your zone time, 2 different times. How do we keep track of time? We are going to talk about the chronometer. So a chronometer is a special clock that's designed for the maritime environment, and it is always on GMT, but it is an analog clock. So it's your, 12 to circle analog clock, but it's always kept on GMT. Now, in order to check to make sure that your chronometer is correct, or your watch, or your whatever Walmart clock you have on board, whatever it is, you can use a time tick, and that's a radio signal that I should have it referenced here, but I don't. You can tune into it, and it will give you these not dits and dahs, but a frequency or a sound on the hour or on the half hour. I think it's not every 6 minutes. It's on a certain time. And it's a series of ticks. Ting, 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 ting. So that's a time tick. And so you can sync up or not sync up. Well, if you can change it, you can, but you're not supposed to change a chronometer. You're just supposed to note the chronometer error. So that's your CE, or the error, the difference between the chronometer and your time tick, or the actual time. Most cases, people just use your GPS and say, that's my actual time. So you might adjust your wristwatch to your GPS. I would say most cases people do that. But if you want to tune into the time tick, you can do that too. So
the purpose of using celestial navigation if you have a GPS aboard?
Yes, but it's a way of checking your GPS. Either way, yeah, you can tune into the time tick if you want. The chronometer rate is your daily change, is your chronometer getting farther away from the actual time or further away from the actual time. So if you got a time tick, 5 days ago, and now you can't find the signal, you can record what the daily change was and get a more accurate time or more accurate reading. And these are all just like small little corrections to get a more accurate LOP. But, generally speaking, even if you don't apply a chronometer error and a chronometer time and you just use your wristwatch, you'll get something close within the, parameters of what you are plotting. So I wouldn't stress too much about it, but they're out there, so understood. There's also the comparing watch. Some people use stopwatches to comparing watch, but I would say most people just use the wristwatch. Nowadays, people use your phone, I guess. Okay. This is the official Bowditch zone descriptions. So, like I said, 7.5 degrees west to 7.5 degrees east is 0, and that's that Zulu time. And then if you're going east, so 15 is the central meridian here, you're at -1. 30, 45, et cetera, et cetera, et cetera. So we are on either +7 or +8. Or if you're on the East Coast, +4, +5. So our basic formula for time is going to be your zone time plus your zone description gives you GMT. So if I was to do that backwards here, GMT minus your zone description gives you zone time. So that's why a lot of you will say, oh, we're at -8 or minus whatever, because you're going from GMT minusing to get you your zone time. So basic formula is zone time plus zone description gives you GMT. If you're in the Western Hemisphere, you're positive. If you're in the Eastern Hemisphere, you're negative. So our first example here is local time is 10:15. We have a zone description of +8. So we're in the Western Hemisphere. Your chronometer reads 6:14:30. Chronometer error, what is GMT? So first we want to figure out, generally speaking, what is our GMT time. So we use our zone time of 10:15 plus our zone description of 8 to get a GMT of 18:15. Now again, our chronometer is analog, so it does not tell you if it's AM or PM. So it's reading 6 hours, 14 minutes, 30 seconds, but because we know what our zone time and zone description is, we know that our chronometer is actually 18:14:30. Then we apply our chronometer error. In this case, it was 45 seconds slow. So we need to add those 45 seconds and add those 45 seconds. We get 18:15:15.
Bree, I'm not sure what you were, how you got 18 from 6.
Okay, so that is going into military time, if you will, or the 24-hour time clock.
Right. 6 hours, no 600, is it not?
If you look at, here we go. We look at this clock and it is pointing to 6. It is either 6 a.m. or 6 p.m. We don't know. So the 6 p.m. is 1800.
Okay,
6 a.m. would be
on the face of the clock then.
What was that?
When you were in the example you were just talking about, in the when you said 6, you meant the face of the clock, not the real time.
Correct.
Okay.
When we have chronometer time, when the chronometer reads something, that is reading the analog clock.
Got it.
And I feel like you're not, I don't know. Has anyone used a chronometer on board?
No.
No? Okay.
Well, I mean, it's just a regular, it looks just like a regular clock, right?
Yes, yes.
So, yeah, it's either...
So maybe you have a clock on board, maybe your standard, you know, Target, Walmart clock, whatever, but that one's always on GMT. You don't know if that GMT is AM or PM, and it's hard to tell just by, is it AM or PM and GMT? I don't know where I am, and you get this, like, I don't know what's going on. So you do your zone description, zone time to get if it's AM or PM at GMT. And then you could apply your error to get the exact time. But like I said, that little difference is just going to be a small difference. And if you're in the middle of the ocean, that's going to be fine. You don't need, you can just go to GMT 18:15. Now,
hey Bree, just curious, maybe I missed it. Where did you get the chronometer error from?
So that's what you take note of when you look at your time tick, or you compare it to a known time. So your chronometer error would just be given to you, like, you know, July 8th, our chronometer error is 40 seconds slow. July 9th, our chronometer error is 46 seconds slow, or 40 seconds slow, or whatever it is. So it's kind of that day. On commercial ships, it's up to the second mate. So the second mate will, he's on watch, he or she is on watch from midnight to 4 a.m. and he will establish the chronometer error for that day. So not everybody has to do it. If you are, again, I don't think any of you guys are really going to use that. But if you are taking a U.S. Coast Guard exam for Celestial, trying to get your oceans ticket or your oceans endorsement, they use chronometer time and chronometer error. And this is how it will be phrased in all of the U.S. Coast Guard exams or questions. So recreationally, practically, you're probably not going to use it. But if you're testing, that's the way it is. Or, yeah, if you're on board a large commercial vessel, which you're not.
Good to know.
Okay.
I found that periodically it doesn't hurt to check your timepieces to make sure that they are keeping good time, because if you have a little bit of error over a period of time, it can add up. So having being able to check your timepieces against each other, or the time tick, or some electronic signal is a good thing if you can do it every now and then.
Yeah. Okay. Did I do this one? Okay. So now we're going to review a quick review of ETAs and how we apply time with ETAs. So ETAs is your estimated time of arrival. And in this case, we're doing long distances if you were to cross an ocean or something. Your basic formulas are your GMT equals zone time plus zone description, and then our beloved 60D street. So our question is, if you depart Newport, zone description +7, on July 4th at 0800, and it takes 10 days and 18 hours to transit, you get transit time to get to Hawaii, zone description +10. When will you arrive in Hawaii? What is the local time you're in Hawaii? So our steps to do this would be to convert the zone time of departure to GMT. So our zone description, or zone time plus your zone description, gives you our GMT time for departure. And then we add our transit time, which is our 10 days and 3 hours, and we get the GMT time of arrival. And if we're going from GMT to zone time, we are subtracting that zone description. So we are subtracting that 10, and we would get an arrival time of July 14th at 0800. Again, I don't know if you're really going to use this by hand, but it's good thing to know to do longhand, just to get the concept of time in. Any big questions? Ooh, fireworks. Any big questions for us? Okay.
It's Janice again. I just want to throw something out there. Be careful about daylight savings time, because I think Bowditch is that table is based on standard time.
Yes.
And your local area may be observing daylight savings time, and not all areas do. And so if your clocks are set to with the daylight savings time, make sure you put that in your calculation.
So, pop quiz, Janice. Where would I find out if a certain island I'm approaching is holding a different zone description than what the longitude is?
You
such
know,
as daylight savings time.
I think it might be in sailing directions. And I think it's in the sailing directions.
Sailing directions. And that's equivalent to a coast pilot.
Yes.
So for those of you who took the coastal nav with me, your coast pilot gives you lots of reference information about the United States. So that's the domestic version. The international version is your sailing directions. Also, if you have internet, you can Google it.
Always.
Is that a map, or you have to look at it each location, and it'll tell you the zone description for that location?
It's a book. So
no, I mean the zone description information. Is that in like a table form, like we just saw, but it's like geographic, or is it you have to look at for each location to see what zone description they're in?
So if you're approaching an island and want to know information about that specific island and what zone description they're holding, you would look it up in a book, such as the sailing directions, and it would give you information about, you know, their national holidays, what zone descriptions they're holding, when they change time, if they do. If you are, and that's for a specific island itself, but anywhere, if you are in the middle of the ocean and you want to hold your local time or your zone time, you would just use your longitude, divide your longitude by 15, and whatever that is your local zone time. Now, some people don't do that. When I'm crossing an ocean on a commercial vessel, it does not matter what we call it ship time. Your ship time can be completely different from the zone time or obviously from GMT time. So it depends on who the captain is and how you want to do time zones. But if you're going from, China to LA in 10 days, and you have to do 5 or 6 time changes, maybe you'll change 2 hours in one day and then take 2 days off, and then another 2 hours another day and take 2 days off. Or you'll change 4 hours or just 1 hour each day, even if you aren't in crossing those meridians. So it's up to the second mate again and the captain to assign those ship time changes. So you could be on watch and the sun is rising at 2 a.m. and setting at noon. Or, it can be all sorts of wonky of whatever your ship is holding versus GMT versus zone time. But for practicality, recreational sailors, I would just hold whatever zone you're in, hold that zone time, because generally speaking, the sun will be rising around 6 a.m., setting around 1800. Again, that depends on what latitude you're at, if you're, in Alaska or at the equator. But generally speaking, when we do our sunset, sunrises, or amplitudes, we always use 6 or 18 as our sunrise, sunset. Anyways, that was kind of a ramble. Did I answer a question? Okay, so technically we have another hour of class left. I am gonna go over some homework, if that's okay. You are free to go if you want. I will be posting, I recorded it today, the tutorial of the homework assignment, but I am going to go over some of it now.
A question.
Yes.
So if, I know that for measuring distance, you use latitude because it's equidistant, but for longitude, you're saying every 15 degrees is an hour, but the lines of longitude converge at the pole, so they're not equidistant. So how can you say that?
Correct. So every 15 degrees is a change in zone description.
Oh, okay.
So at the poles, those zone descriptions happen a lot quicker.
Oh.
And at the poles, it stays, light longer during the summer, and it's dark during winter.
So is that
whatever pole you're at and whatever sun or whatever season it is.
Is that why there are zone descriptions? Because the lines of longitude aren't equidistant? Maybe.
Yes. Generally speaking.
Okay.
Okay. So I am going to. So can you all see my little whiteboard?
Yeah.
Yes.
We're on the document camera now. Okay. So for your assignment number 1, which is going to cover week 1, we have defining the following terms. So I'm going to let you go over that on your own. Then we have our time diagram practice. So I'm going to do that with you right now. Then we have our navigational triangle review. So I'll do that with you. And our practicing time. So I'll do that one with you guys too. And then we have just copies of compasses. So if you want to get real accurate on your time diagrams, you can use these. That's why they're there. But I usually just draw a circle, which I will show you. Okay, so that's my plan.
Hey, Bree, quick question.
Yes.
My understanding is that the Schlereth book is part of this class, but I don't see any reading assignments in it. Are you going to give any specific reading assignments in it, or is it just kind of like for a reference?
It's just for a reference. So I like to teach my classes mostly by lecture, by PowerPoint. And then if you are more interested in a subject or a topic, or you didn't quite get what it was from my lecture, go ahead and look it up in the textbooks or, YouTube videos or Google. There's so much information out there. But I will not have reading assignments. I will be posting the PowerPoints a week ahead of time. So I might even just post all the PowerPoints. That way you can review those before class if you'd like. I guess, again, my lecture style is rambling on or talking. So some of my PowerPoints are just, more pictures than written words, I guess. But I think the basic definitions I have written out in the PowerPoints. So I would say reference the PowerPoints.
Very good.
Okay. If you've had class with me before, you also know that I like my colored markers. Okay, so let's see, number 10. We have a position of 21 degrees, 18 minutes north, 154 degrees, west. The sun. So the symbol for sun is a circle with a dot in it. GHA is 090 degrees. And it's asking us if it's AM or PM and what our LHA is. So I am going to draw my time diagram. So I have Greenwich. And first I'm going to draw my longitude. So if I'm, here, let me draw. This way will be west, and this way is east. So if I want to draw where I am, I'm 154 degrees west. So from Greenwich, this is approximately 90, this is approximately 180. So 154, generally speaking, would be there. And that is where I am. So that is my longitude. So if I make this line, that is what my longitude is. Now I want to write in what my sun is doing. So my sun, GHA, is, I didn't write out, using my little notes here. Can you see that? GHA is from G to the star, or G to the sun. So from G to the sun is 90 degrees. So I would say here is my 90 degrees GHA. So from Greenwich to the sun is 90. From Greenwich to me is my longitude. So let me write out here. So we have GHA is G to the star. LHA is me to the star. And little t is me to the star, east or west. Okay. So LHA, I guess my first question was, is it AM or PM? Any guesses?
PM.
AM.
AM. So the sun was over here. It would be midnight. If the sun is directly above me, it's noon. So it's past midnight in the AM hours, not quite to noon, and then it would be in the PM hours if the sun was over here. So we are AM. And to figure out LHA, LHA is from me to the star measured westward. So from me to the star measured westward. So measured counterclockwise. So I have a large number here. Yeah. Also, write this down in your notes somewhere. I guess I didn't write it down. This is going to be your formula or your part of your site reduction form that you need to know if you don't understand the time diagram. GHA plus east or minus west longitude gives you LHA. That is our big formula we're working with. So basic part of our site reduction form, GHA plus or minus longitude gives us LHA. So I know my LHA is going to be a big number. And if I put in my numbers, this was 90, and this green one was 154, and you are spatially on top of it, maybe you could calculate it out with the circle, but I'll give you the number way here. So it's GHA 090, and we are minusing 154 degrees because we are west, so we're minusing. You can't minus 154 from 90, so what we do is add 360 to this. So we change this to 4, I don't like doing math in my head while I'm being recorded. 450, yeah. So 450 minus my 184, my calculator here, minus 154 gives me 296. So that would make sense that this angle is a little bit more than 270, or about 3/4 of a circle in my rough sketch that I have here. So just a simple little sketch. But I can check out that, yes, my LHA would be 296. Now the next question was T. What is our meridian angle? Our meridian angle is from me to the star. So from me to the star in the shortest possible distance. So 296 degrees, not the shortest possible distance. So from me to the star, and that would be measuring east, I need to figure out what number that is. So I'm going to do 360 minus 296 gives me little t. I'll get my phone to work here. 360 minus 296 gives me 64 degrees east. Another way to check that, if I have 154 degrees as my longitude and 90 degrees as my GHA, that would make sense that 64 degrees would be my meridian angle.
So, Bria, I'll ask you a stupid question. Why wouldn't you just subtract the your longitude from the
your GHA from the longitude?
Right.
Because that works in this situation, but it might not in all concepts of what if the sun was on this side, adding or subtracting. So
I mean, it works if they're in if they're both in the same hemisphere then.
And depending, not on the same hemisphere, of if it's AM or PM at your,
okay,
if the star is past your meridian or not.
Okay.
So this time diagram is the same in the northern or southern hemispheres. We're not even talking about north or south.
Right.
This is all about longitude or hour angles.
Right. Hemisphere was not the right word, but it's basically on the same side of the well, never mind.
Yes. I think I get what you're saying. That if you think about it in like the simple little rules of little t is from me to the star in the shortest possible distance measured east or west, that will work all of the time. So I guess I would just say simple, and GHA add east minus west longitude equals LHA, that will work all of the time. So you don't really need to know this time diagram. You don't need to know this. If all you want to do is measure, is just, you know, get the numbers in, then this little box, this little formula is really the only thing that you would need to know. And then if you wouldn't even need to know little t for any reason, I'm gonna say, nope, you wouldn't need to know little t. So really, GHA plus east minus west longitude equals LHA is what you're taking away from today's lecture. Okay, so that was number 1. Let's do number 2, or sorry, not number 1, number 10. Okay, so those are our memory things. We're really gonna focus on that one. Okay, so number 11, we have a position, a longitude, a sun, GHA is 235. Okay. So I'm going to start with where I am, and I am 117 west. So I'm going to be going this direction by 117. So give or take. That's where I am. And the sun is at 235. So here's 180 and 270. So 235. Sun would be approximately over there. So AM or PM?
PM.
PM. The sun is setting. It is past us. So we are in the PM. So sorry. This was our GHA. This was our longitude. And LHA is from me to the star measured west. So from me to the star would be our LHA. And when we go to our formula, GHA add east minus west longitude gives us LHA. That would make sense. Our GHA is 235. Our longitude is 117. So we are subtracting our longitude from our GHA to get our LHA. What's our LHA?
$118.
118. And if we want to convert that to little t, it is the smallest possible way to get to the sun from me would be 118 degrees west. I'm kind of rethinking my PowerPoint here that maybe the little t just throws in confusion. I really don't think you're going to use that. Again, this is my first time teaching Celestial at OCC in such a condensed version to recreational boaters. So please, I would love more feedback from the class, just so it can be better throughout the next years. If you find typos in the homework or the PowerPoints, please let me know. I do not get my feelings hurt. It's kind of a work in progress. You guys are kind of my guinea pigs. But
one thing that I think would help is, you're throwing lots of acronyms out here, it's lots of definitions, lots of arithmetic, but what are these used for in our process here? Why would we care about LHA or GHA, for example?
So when we go to our book, we need to go in with LHA. Okay. So we need to calculate LHA, our latitude, and our declination.
Okay. Okay, and that's fine. Okay, you go to your book and get something from the book. What is that something that you get from the book?
That's something we get from the book. Goes back to that that little symbol where I had the GP of the star, and then we have an assumed position, and then we have to calculate that intercept to get our LOP.
Got it.
So we use our assumed position to get LHA into the book, and that calculated versus observed. So this would be a calculated position. This would be an observed position. Gives us that LOP.
Got it. Okay.
In a very rudimentary.
So you use LHA, and then you go into the book, and the book gives you the intercept and what do they call it? The distance and the direction, right?
The Nautical Almanac will give you your GHA.
Okay.
And declination.
Okay.
Then you have to convert your GHA to LHA.
Okay.
To go to this book, which gives you your calculated altitude and your calculated Z.
Okay.
Then you convert to ZN, and then you can plot.
Okay.
Your LOP.
Yeah, I think it would be useful to kind of give that information up front, and then you understand why we're going through all this.
Okay, that makes sense.
Yeah, kind of an overview of the process, and then some of this detail here.
Gotcha. Okay. Cool. I will get something like that. Okay. Let's do number 12. Position. Altitude. Okay. Okay, so where am I? I am 75 degrees east. So from Greenwich, I am east this time, 75 degrees. So that's 90, say right about there, is where I am. I'm in the Eastern Hemisphere. And then I'm going to put my sun. So from Greenwich, measured west, my sun is right here at 300. So that is 350 degrees. That is 75 degrees. So that's the information that I know. And then I want to figure out what my, or what is it AM or PM?
PM.
PM. The sun is always going counterclockwise, so it is past noon. So we are in the PM hours. And LHA, we need to get LHA. So LHA is from me to the star, measured west. So from me to the star, measured west. So I know it's going to be a small number. So I have GHA, add east minus west, gives me LHA. So I have my GHA of 350 and my longitude is 75, and I'm going to be adding it. So I have 350 plus 75 gives me 425. 425 doesn't exist, it's too big, so I minus 360 from it, and I have an LHA of
65.
So that would make sense with my picture that if this is 75 and this is 350, this is kind of that -10, that 65 degrees would make sense. So good mental check. Again, with the little t, meridian angle, you're going from me to the star, the sun, in the shortest possible distance. So it would be 65 west. Okay.
West or east?
What?
West. Yeah, okay,
West.
got it. Yep. Keep going around.
Okay. Number 13. We are 14 degrees, 48 north, 142 east, sun, GHA, it is 25 degrees, 2.5 degrees. Okay, 1 second. Okay, so where did I go? Let's start off with me. I'm at 142 east. So from east, I am 142. So that would be my longitude is 142 degrees east. Then I have my sun, which is measured west from Greenwich at 225. So 225 is going to end up somewhere around here. As my GHA of 225. And so then I need to figure out what my LHA is, and that is from me to the star. So from me to the star measured west. So I know it's going to be a small number. GHA at east minus west gives us LHA. GHA is 225. I'm going to be adding my 142. So I have 225, oops, 225 plus 142 gives me a large number, 367. So my LHA is 7 degrees. And my little t would be 7 degrees west as well. Okay. So our main point of this was getting that GHA at east minus west equals LHA conversion. And we can make sure our LHA is ballpark the right answer by doing a time diagram. So that's why that helps, but don't sweat it too much. Just some ballpark information. I was telling my brother-in-law I was teaching Celestial. He's went to the academy as well. And he was like, oh, are you going to do time diagrams as a joke? Because he still doesn't understand time diagrams.
A question, Bree?
But yeah.
Just a question. So you're using an assumed position to start that time diagram?
So the assumed position, so the time diagram is, what we were doing there was just like a rough estimate of where we are. But when we are actually plotting our position, we create a, an assumed position, so we don't have to interpolate 3 ways. We only have to interpolate 1 way, and that's why we do an assumed position.
And that assumed position is kind of, I mean, how would you describe it? Just a ballpark guess based on your dead reckoning, or?
It's, okay. We're diving real into it, but I feel,
yeah, sorry, I know it's just a time diagram, but I kind of wondered, you know, okay, well, if we're going to do that to make sure you're in the ballpark, I guess you got to get a navigational position that's in the ballpark.
Yes. So when we go into your site reduction tables, you are using 3 things: your LHA, your latitude, and your declination. So what we assume, we create an assumed position with our latitude. We just ballpark it to the nearest whole degree. So I don't know, what was our zone? We had, let me get a west one here.
Say 118.
28 degrees, 36 minutes north, 125 degrees, 39, 3 minutes west. Okay, I'm just pulling that off of one of our homework examples. So that is my DR position. Now, in order to plug this in to get an assumed position, I'm just going to assume to the nearest latitude. So I'm going to say my latitude will be 29 degrees north, whole degree. And then for my longitude, or for my LHA, I want this also in a whole degree. So in order to get that, I would calculate my GHA. Okay, I'm just gonna make a GHA up here. What do we have? 225 degrees as our GHA. I'll just say, yeah, 52 minutes. So say I went to my nautical almanac and calculated what my GHA would be. So it's our GHA. I calculated that. Then I'm going to get my assumed longitude. So our position has an assumed latitude and an assumed longitude. And I want my LHA to be a whole degree. So my longitude is west. I'm going to be subtracting it. So I'm going to say whatever my longitude is, it's going to end in 52. So that my LHA will be a whole degree. So this is my DR longitude. I'm going to say, is 52 closest to 125, 52, 125, or 124, 52, or 126, 52. In this case, it's 125. So when I get my LHA, I have 225 minus 125 gives me an LHA of 100. So now I could go into my book to get a solid LHA, a solid latitude, and the only thing I have to interpolate is declination. So then we would be interpolating declination. So from there, I know that was a lot of information. From there, I plot my assumed position. Oops. My assumed position is 29 degrees north, 125. Oh, wait. I have an example of this. Okay, so can you see that? On here, I have assumed position 1, assumed position 2, and assumed position 3.
Bree, can you straighten it up a little bit so we can see the longitudes on the top there? You're cutting off. There you go.
Perfect.
Did I get one on that one? No. So again, this was for a different problem. We're in the Eastern Hemisphere here. But I created these assumed positions by getting by wanting to get an LHA as a whole degree and a latitude as a whole degree.
I got you.
So I created, so that's why all of my assumed positions are on a solid latitude line.
Okay.
So you create your assumed position, and then your ZN is your azimuth. So that bearing is going to give you that that azimuth line from your assumed position. And then I don't know what this is if I'll use it again, but the difference between your assumed position and let me draw this on here. So here is the GP of your star. And here is your assumed position. So okay, and then this is your ZN, the bearing of your star. So we're getting a bearing and a distance, like bearing and distance, two LOPs here, or 2 factors. We're only getting 1 LOP. Okay, so we created our assumed position. So this is our calculated altitude, or H, our calculated height from using our assumed position. But our observed height gives us something like this. So the difference between your HO and HC is called the intercept. And so that distance right there of the intercept is what this distance is. So I created a azimuth line, and then the intercept is this distance here. And then I draw, so I'm saying I am somewhere along this line as my observed altitude. That is my LOP. But when I draw this line, I draw it as a straight line that is perpendicular to my azimuth line. So the actual LOP that I'm drawing and using to plot is perpendicular to my Z. How are you guys feeling about that?
Well, my eyes have glassed over, but I get where you went with that, and I understand now why you put the assumed position on a whole number in terms of that, to get your numbers right. Okay.
Yeah. It will make more sense as we build with this information.
Mm-hmm.
Next week, we're going to dive into how you get this information. So next week, we learn how to get GHA and how to get declination, and where to how we get that. And that's in the Nautical Almanac. And then the next week, we learn how to convert that using our assumed position into an actual LOP. So, yeah. What do we got? We got 25 minutes. Shall we dive into time, or do you guys want to take a breather and call it a night, digest on what we talked about? Keep going?
I'm going to take a breather.
Take a breather. Let's take a breather. I will be posting this hopefully tomorrow of me doing all the problems 1 through 19. So there will be a YouTube video of me doing it. Next week, I'll start off with any questions you had on the homework. But if you have some big questions on it, look at the video just to see if I answer it in the video. Of course, you can email me or call me. Do you guys have my information from anything? Here, let me write it down. Or I'll send it to you. We'll do a little send thing.
I think it's on the sheet that
it's on your it's on your cover sheet.
Oh,
right
okay.
under the outline.
Okay. So yeah, feel free to contact me anytime if you're just stumped on something. Or take a picture of it and text me, and I'll try to help you out. So next week, we'll go over the homework a little bit, but we're not going to dive into it much. We're just going to move forward into the Nautical Almanac. And then we're going to practice using the Nautical Almanac. So that's why I would recommend getting a whole book, because we'll be flipping back and forth to a bunch of different dates as examples. So I'd recommend getting the book. And then the next week we're gonna dive into plotting. So that's the one you guys are all waiting for. I know it. But yeah, I hope you enjoyed the class, and let me know any comments, concerns, or questions. I am open.
Thank you, Bree.
Thanks, Bree.
All right.
Great job.
Have a good one.
Thank
Thank
you.
you.
See you next week.
Bye.
Bye.
Bye.